Here we are at example 3 from our 2.37 notes. We're asked to find the equation of the tangent line for this particular function at this particular x value. Now, anytime we're trying to figure out the tangent line of a function, we know that we first have to find the tangent slope of it. So I'm going to go ahead and just rewrite the function f of x is equal to 4 minus 4x plus 2 over x. And essentially, also I can go ahead and rewrite this as f of x is equal to 4 minus 4x plus 2 times, I'm going to go ahead and take this x, which is on the bottom, throw him on top, and change that positive exponent to a negative. Because if you bring something up to the top that's already on the bottom, you simply then just change that exponent to a negative. So as a result, these two actually mean the exact same thing. Now we can go ahead and take the derivative a little bit more easily. So when we take the derivative with respect to x on both sides, we end up with f prime of x is equal to the derivative of a constant just comes out to be 0. The derivative of negative 4x just comes out to be negative 4. And using that power rule with this last term, we end up bringing this negative 1 out into the front. So we have minus 1 times 2 x, and then subtracting 1 from our exponent. So ultimately, it looks like our exponent comes out to be negative 2. Cleaning this up a little bit, we end up with f prime of x is equal to negative 4 minus 2. And since we have this negative exponent for x, we can go ahead and just like we did earlier, where we brought something up to the top and made the exponent negative, we're actually going to take this entire term and throw him on the bottom and make that exponent positive now. So then we would end up with x squared on the bottom. So here is our derivative of our original function. Now we can go ahead and determine what is the slope of the tangent line, specifically at our target x value 1. We accomplish that by pretty much just throwing 1 in for x. So again, the slope that is tangent to the function at this particular 1 value comes out to be negative 4 minus 2 over 1 squared. Simplifying things further, we see that it comes out to be negative 4 minus 2, which then just comes out to be negative 6. So our tangent slope, specifically at 1, comes out to be negative 6. Now we have our target x value, but we actually also need our target y value to then construct the equation of the line. So to find the y value, we're going to go ahead and take in our target x and throw them anywhere that we see an x into the function. So then f of 1, in other words, just throwing 1 into the function, is equal to 4 minus 4 times 1 plus 2 over 1. And this will simplify out to be 4 minus 4 plus 2. These just cancel out with one another, so it looks like our y value comes out to be 2. So then our point is 1, because we threw 1 in for x, comma 2 for our y value. So here is our target point. And here is our tangent slope. Now to construct an equation of a line, we know that we can use point slope. And point slope is y minus y1, which is equal to m times x minus x1. From here, we just throw in our knowns. So when we do that, we end up with y minus 2 is equal to negative 6 times x minus 1. And now from here, it's just algebra. So we would distribute this negative 6 in, end up with y minus 2 is equal to negative 6x plus 6. And lastly, add 2 to both sides. So it looks like y is equal to negative 6x plus 8 is the equation that is tangent to our function at this particular target point, 1, 2. So again, though, that is example 3 from our 2.3 number 2 set of notes.